Okay, good morning everyone. In the previous presentation, we discussed about the concept, the functional groups. Okay, in that functional group, we already discussed about alcohols. And in this presentation, we are going to explain another one functional group is carboxylic acid. Carboxylic acids. Okay. So the functional group carboxylic acids, they ends with COOH and their name ends with the suffix oic acid. Okay. Their functional group consists COOH group and their names ends with oic acid. For example, the first one is alkane, is methane. How to convert the methane into respective carboxylic acid? Methane with the molecular formula CH4. Here one carbon is bonded with the 4 hydrogen atoms. 4 hydrogen atoms. Here we have to add COOH group. And how to convert this methane into respective carboxylic acid? Here only if one carbon atom is present, that is called methane. So here just remove add COOH. Just modification, it is by removing 3 hydrogen, just add this group COOH. And then here name is added with the suffix oic acid, then it becomes methanoic acid. Methanoic acid. And next, second one is ethane. How to convert this ethane into respective carboxylic acid? Here C2H6 is the molecular formula of ethane and the structural formula is this is the structural formula of ethane. How to convert this ethane into respective carboxylic acid? Same thing, for one carbon just add the functional group, and here 4 bonds satisfied. The first one is write 3 hydrogen and it has become ethane. Just replace E with oic acid and it has become ethanoic acid. Ethanoic acid. Another chemical formula, that is CH3COOH. Molecular formula of ethanoic acid is CH3COOH. Okay. This is how we convert the respective alkanes into their carboxylic acid. Methanoic acid, ethanoic acid, and next propanoic acid, butanoic acid, etc. And the next functional group is aldehydes. Aldehydes are the functional groups and they consist COH or CHO as the functional group and their name ends with suffix AL. And how to convert the respective alkanes, alkenes or alkyls into aldehydes? By taking example, it is propane. Propane with the molecular formula C3H10. C3H10 and the structural formula is C3H8. Propane. Okay, how to convert this propane into respective aldehydes? Here just remove these hydrogens and it is modified into again 3 carbon. Just add the functional group COH and then satisfy a carbon with number of hydrogen, maximum number of hydrogen. And this is propane is converted into, just replace the letter E with Al and it becomes propanol. So this is the way convert the alkanes into respective aldehydes. And another example is pentane. How to convert this pentane into respective aldehydes? The molecular formula of pentane is C5H12. Okay. Now write the structural formula. 5 carbon with 12 hydrogen. Pentane. How to convert this pentane into respective aldehydes? Same thing, the last one. Okay, and it becomes write the functional group and then satisfy all the carbons with maximum number of hydrogen. Okay. Now this pentane becomes pentanol. Okay, it is converted into alkane, is converted into respective aldehydes. Okay. And the next functional group is ketones. Ketones are the functional groups with CO as the functional group and their name ends with 1. How to convert alkanes into respective ketones? By taking the example butane. Here 4 carbon, 10 hydrogen. C4H10 is the molecular formula of butane. Then the structural formula is C4H10. Then how to convert this butane into respective ketones? Now here the carbon is placed, the functional group is placed in between the carbon atom, either between second carbon or the third carbon. Now it becomes CO, functional group is added, then satisfy carbon with maximum number of hydrogen. Here it is butane. The butane is converted into, just replace the last letter E with 1. It becomes butanol. Okay. The alkane is converted into respective ketone. Okay, next it is pentanol, hexanol, heptanol. But here the condition is it requires minimum 3 carbon atoms. That is, ketones groups are starts with the 3 carbon atoms, that is from propane. Because in order to add the functional group CO, it needs minimum 3 carbon atoms. So the ketones are begin from the compounds with the 3 carbon, that is propane. Okay, this is the condition. And the next one is halogens. Halogens. How to add the halogens into the, that is chlorine, or bromine. By taking example, that is a simple example, methane CH4. Here carbon is bonded with 4 hydrogen. Here 4 and is bonded. And here just replace 1 hydrogen with the chlorine. Okay, and it becomes, just replace 1 hydrogen with the chlorine and it becomes chloromethane. Is chloromethane. Chloromethane. Here we add the word chloro. If it is Cl, is chloro. If it is Br, bromo. We add the prefix is bromo. And here it is for chloro. If it is Cl, it is chloro. If it is Br, it is bromo. Okay. And the next example is C2H6 ethane. Here 2 carbon is bonded with 6 hydrogen. Just replace 1 hydrogen with the Br and it becomes bromoethane. Here we have Br group halogen, so it is ethane, bromoethane. Okay, this is how the alkanes are converted into respective halogens, haloalkanes. Either it may be chlorine or bromine. Okay, if it is added with the chlorine, it is called chloromethane or chloroalkane. If it is added with the bromine, it is called bromoalkane. Okay, and this is regarding the functional group. In the functional group, we already discussed about alcohols, carboxylic acid, aldehydes, ketones, and halogens. How to convert the particular alkanes or hydrocarbons into respective the functional groups. How to add the functional groups. And the next concept is aromatic hydrocarbon. Aromatic hydrocarbons. Okay, it is a special group of hydrocarbons. Here, the aromatic hydrocarbons, they consist at least 1 benzene ring. 1 benzene ring. And what is this benzene? Benzene. Okay, benzene is a hydrocarbon, aromatic hydrocarbon, and its molecular formula is C6H6. C6H6 is the formula of benzene. Then how to write the structure? How to write the structure of benzene? Here 6 carbon is bonded with 6 hydrogen. And here the bonds are not satisfied, so put alternatively single and double bond. Here double bond, single bond, and double bond, single bond, and double bond. Alternate single and double bond. Now the valence is satisfied. First carbon is bonded with 4, and second one is bonded with 4. Okay, 4 bonds are there. Otherwise, how to write the structure? Like this also I have to write. And here write alternate single and double bond, single bond, double bond, single bond, and the double bond. This is also the structure of the benzene. Or change the position of the double bond. Here double bond is there, single bond, double bond, single bond, double bond, single bond, and the double bond. This is also the structure of the benzene. Otherwise, if you confuse, then write like this also. Write a ring in the middle. This is also the structure of the benzene. Okay, all these are the structures of the benzene. Then, what are the compounds other than the benzene? If 2 benzene rings are arranged like this, it has become naphthenic. If two benzene rings are joined like this, the name of the compound is naphthenic. Otherwise, if one benzene ring is attached with CH3 group and it is become toluene. Okay, these are the aromatic compounds. At least they have one benzene ring in their structure. Okay, this is regarding the aromatic hydrocarbons. Okay, try to write the structures. Don't make confusion in writing the single and double bond alternately because the valency is not satisfied. Okay, if you write the double bond together, okay, there is no balance of the valency. So be careful while writing the structures and try to write the structure as much as possible. Okay, written work is needed. Thank you.